What's up? What's up? What's up? What's up? What's up? Let me tell you something. Listen carefully. Once you go flat, you never go back. I'm just kidding. That sucked. This is Sid Boson, your friendly neighborhood science nerd. Today, like it mentions in the title, we're going to talk about flat earth theory and why it sucks. I'm going to tell you 3 reasons why the earth is not flat, and hopefully if you're not a flat earth theorist, you'll be convinced by the end of this video. And if you're not a flat earther, you'll have 3 strong reasons to convince a flat earther on why the earth is not flat. And watch till the end of this video, because we're going to be playing a video of Dr. Neil deGrasse Tyson rapping and destroying a flat earther, and that video is epic. I'm sure all of you are going to like it. So before we roll the intro, hit that like button, hit the subscribe button, and watch till the end. Roll the intro, Martin. Follow your passion might be a perfect question to ask and might have a perfect answer when interpreted right.
Let's start tracking which stocks can actually go up and go down, or which stocks have an advantage with the vaccine coming out.
Why it would have been more expensive to fake a moon landing back in those days. It's quite an interesting video to watch.
The economic activity created from the App Store alone is worth $500 billion.
So let's move on to the next question.
Man, it was too easy.
Too easy, no? Why didn't you answer?
All right, welcome. Let's get started straight away. Now, before I actually get into the reasons, a little bit of flex, a little bit of credibility. My name is Sridev. I have a degree in astrophysics from the Open University. So, you can take my word for it. I'm credible enough to talk about this. Have done my research, have studied astrophysics and a lot of astrophysical phenomenon for like 4 or 5 years, and let's get straight into it. Cool. You know what, the first thing that actually comes to my mind whenever I hear about this whole flat earth thing is, why do we still have people who actually believe that the world is flat? Like, for someone, it seems like one of the most obvious thing. Like, we grow up looking at pictures of earth that is actually round. I literally have something that is right behind me, which is like the spherical earth, which is revolving. But the first question is like, why exactly do people even believe that the earth is flat? And believe it or not, there are actual conventions that actually happen in the United States. There's a yearly convention known as the Flat Earthers Convention, where people actually come together. They have lectures from people. There are a lot of people who are making, bizarre little theories on why the earth is flat. They have a lot of sub theories like the earth is hollow and stuff like that. There is merchandise, obviously. Capitalism can't help it, but you can literally buy like t-shirts, and you can actually buy models of the flat earth. Like usually in your schools you might have like globes and stuff like that, but in flat earth conventions people don't have globes. They have actual models of the flat earth, and these are like really fun videos. Vice actually has a very interesting video on this. Highly recommend you guys go and watch it. But we'll get to why I think people actually believe in flat earth theory towards the end. But before we sort of talk about that, and before we hear the badass rap from Neil deGrasse Tyson, I'll give you 3 simple reasons. Simple, easy reasons. You don't need any scientific background for this. You don't need any prior scientific knowledge for this. This is simple, logical stuff. Okay, if you just apply your mind, if you just sit with me here, apply your mind with me for the next 15-20 minutes, you will be able to visualize this perfectly in your head, and you'll be able to explain it to someone else. All right? You guys ready? If you guys are ready, type ready OP in the chat. Generic, but whatever. Cool, awesome. Let's get into it. First reason, okay, this is one of the most obvious reasons that anyone will ever give you, and this is basic stuff. Like, this is stuff that even a 5th grader can understand. This is a reason that even a 4th grader would know, and they can sort of talk about it to their friends and stuff like that, okay? You are on a beach, or let's say you're on a beach, okay? You're on a beach. Your friend is actually sailing in a ship, and your friend is actually going somewhere. Your friend is actually sailing in that ship, and they're going to some other country, or they're going on an adventure, and to try to find an island and stuff like that. So you bid your friend farewell. Your friend is on that sailboat, and this is like a normal sailboat. Okay, I'll even help you describe the ship. It's a sailboat. It's a normal sailboat. It's got a mast. It's got a really tall mast, and it's got its sails. Okay, simple stuff. Now, your friend said goodbye, and your friend is like sailing away into the distance. Your friend is sailing into the horizon. It's a beautiful, lovely, lovely sunset. You're totally enjoying the view, but you just want to see. The experiment over here is we're trying to visualize how we would actually see the sailboat vanish into the horizon. Okay? Two scenarios. If the earth is round, if the earth is flat. Right? Let's consider the first scenario. If the earth is round, what would be observed? The surface of the earth would be curved. Okay? So the sailboat would actually start from this one point. It would go into the distance, and the further it goes, you'll see it fainter and fainter, which is kind of obvious, which happens in both scenarios. But if the earth is round, one thing that you would see for sure is that the bottom of the sailboat would start disappearing slowly. Like the base of the sailboat would disappear first, and then the top portion, the middle portion would disappear, and the only thing that you would be seeing is the sail. Like you won't even be able to see a friend at this point. After a point, half of the sail has disappeared, and towards the end, the only thing that you'll be able to see is the top of the sailboat. Okay, this is something that is expected in a curved environment, because let's say you're here on the top and the structure is curved. So when a ship is moving further, the bottom is actually moving towards the curved section, and you can still see a little bit of the top, and it keeps moving, and the top also keeps vanishing. Okay, this is one thing that you will see if the world is curved. If it was flat, what would you see? If the earth was actually flat, or if a sailboat were to actually move in a really flat surface, what you would expect to see is, just like in the first case, it would get fainter and fainter the more distant it is. But one thing that you would not see is you won't see the bottom of the sailboat disappearing. You won't see that whole progressive disappearance from the base of the sailboat to the mast of the sailboat. You won't see that whole dramatic thing that's going to take place. All you'll be able to see is you're going to see the sailboat at its full the entire duration of however you're watching it. But the further it goes, the fainter it gets, and after a point, it just becomes a dot-sized thing that you see somewhere in the distance, and even that will vanish off. Okay? So these are the two scenarios that is expected from both of these conditions. Okay? Curved, mass disappears at the end. Here, nothing really disappears. It's just that it gets fainter and fainter and fainter and fainter, and finally you don't see it. Okay? Simple stuff. Now, what do we actually, so these are the two hypotheses that we have based on the conditions. Okay? Curved, straight. Sorted? Now, what do we actually observe here on Earth? If you were to actually go out to a beach, and if you have a beach, don't do it now, it's freaking COVID, sad. But if you ever get a chance, I want all of you to observe it. And I want all of you to sort of question these things. Like, these are really things that all of us take for granted, and we don't really bother to question any of these things. Like, we used to ask a lot of these questions, like, why is the sky blue and why is the leaf green and things like that. But there's a whole dimension of fun when you actually question the most basic things, and you take there's a kind of pleasure that you get from sort of validating these things, because in what you're actually doing is you're performing experiments. You're questioning your existing ideas in your head, and you're trying to sort of break that down in your head. And there's a really unexplainable kind of joy that you sort of get out from this. So I want all of you to go do this when things are like fine and all that. Whenever you are at a beach or at a port, I want you all to sort of do this actually. But from experience, and from anyone's experience, and this is kind of intuitive for all of us, if you were to actually do it, you would see the first scenario and not the second scenario. Even when a sailboat is coming towards us, you don't see the entire ship slowly becoming translucent and suddenly turning like completely visible. That's not how it works. We see the mast, we see the top of it first, and then we slowly start seeing the bottom sections, then we see the middle, and then we see the body of the sailboat or the ship or whatever thing that you're actually watching. So this is what is really observed in nature, and this tells us, this is the first point of proof. This was one of the first points of proof that actually told people that the earth is actually not flat, it was round. And this is what sailors knew it all the time. Like, we were sailors. Earlier, one of the greatest ways that people used in order to travel, a lot of great explorers used this to actually travel. They knew it. They knew the earth was around 2,000, 3,000 years ago. And we've always known it. We've always known why the earth was actually round. And this is one of the best visually convincing reasons that we can sort of establish in order to prove that the earth is not flat and it's round. Point number 1 taken down. Let's move on. Point number 2 is super interesting. This is an interesting story, okay? And for this story, I'm going to take you back to ancient Greece. Okay, in ancient Greece, there was a scientist. His name was Aristoxenus. Damn, that was a tough name. I was about to say Aristotle. Aristoxenus was a really popular, he was a really intelligent scientist back in ancient Greece. And 2000 years back, he calculated the circumference of the earth. He established that the earth was actually round 2000 years back. We did not have satellites, we did not have images, we did not even have a plane. There was no way he could even go up to see anything. But he actually established that the earth was not flat, it was actually round, it was a sphere. And he calculated quite accurately the circumference of the entire planet, and which is quite impressive. And even if you actually look at that value right now, it is correct to a couple of percentages. That is freaking insane. And this exactly shows how powerful math is, and this exactly shows how we can decode things about the world even by not seeing the bigger picture. Like, slight deviation. One of the things that I always get from a lot of people is that, hey, we haven't seen certain things, so how can we sort of prove it, and how do we know that it actually exists? And the short answer for that is this: you don't really need to see the entire picture to sort of prove it. You can sort of take data, you can sort of take indirect observations of certain things, and from that you can form certain correlations, which actually gives you a model of the bigger picture, which is the power of physics and mathematics where we're at. But now, coming back to the entire story, okay? So what this guy basically observed was that in different cities, so for example, there was a city called Syene, okay? There was a city called Syene, and in Syene there was a well. At a certain time of day, okay, let's randomly say 12 o'clock. I'm not sure if it's 12 o'clock or 1 o'clock or whatever it is. Let's say it's 12 at noon, okay? At a random time, 12 o'clock in the noon, in Syene, Aristoxenus actually could see the sun inside the well directly above. Like, if he just looked at the well, he could see the entire disk of the sun. And what did this mean? This meant that the sun is at a point that is directly above him. Okay, it was not at an angle, it was not slightly here, it was not slightly there, it was straight above him. Okay? In a city which was just a couple of 100 kilometers away, known as Alexandria, in Alexandria, there was a similar well. But in Alexandria, at the same time, he did not see the sun was actually straight up. He saw the sun was actually at an angle. Not the entire disk of the sun was actually visible in the well. It was actually at a slightly different angle. Now, here's the thing. Even in flat earth, this whole thing is possible, wherein in one well you have a different angle and in another well you have a different angle, because the surface is flat. Here you can sort of see it right above you. Here you would expect to see it at an angle. But what he did was, there was a third well. There was a third well of reference, and what he did was, he calculated the angles at which the sun was incident on it. And when I use these complicated terms like incident, it basically means where the sun was in the sky relative to the ground. Okay? When the sun was directly up, which means it's like 90 degrees. Okay? So he calculated those angles, and from those angles, when he applied it to certain mathematical equations, which were like pretty simple basic geometric equations. Even the word geometry is actually defined from the word earth. Geo means earth and metry means measurement. So the measurement of the earth. So this is actually one of the birth points of the word geometry itself. Fun fact. So he took these measurements of these three wells, and the angles were such that it would have been impossible for him to get these kind of varied angles if the earth was flat. The only way he would have gotten such different angles in these different cities at the same time would be if the earth was actually round. So this is a second way that Aristoxenus used the power of mathematics and physics in order to prove that the earth was round. And this is actually one of the first mathematical ways that we as human civilization actually proved that the earth was not flat and was actually round. And using this whole technique, he sort of expanded it to a larger kind of an area. It's not like he went all around the world looking for wells, to see how the sun is shining its lights on it or anything like that. I'm not going to get into much complicated stuff, but using this as the basis, he built upon this idea, and eventually he found out the circumference of the Earth, which even when you compare it to today's value, which is quite very accurate, it was accurate to a couple of percentages. Like it was probably like 1 or 2% off, which is crazy. 2000 years back, this guy had literally no kind of measurement devices, and the measurements were really poor, and he still got it right to a crazily accurate level. That's the power of mathematics. All right, point number 2 down. Point number 3, this is something that all of us can still do, okay? I'm pretty sure all of you don't have the time or the patience or the enthusiasm or the energy to go looking for wells and do angle measurements and stuff like that. I personally don't like it. It's freaking boring. But the third one is really interesting and it's very beautiful, okay? The third point is a lunar eclipse, okay? If you have seen a lunar eclipse, put lunar eclipse OP in the chat. I am a huge fan of eclipses. I love all these kind of astronomical events like meteor showers, eclipses and stuff like that. And I look forward to these events. And I actually have an astronomical calendar right here on my laptop where I mark, I keep reminders for different astronomical events that are about to come. And whenever they come, I go up and I watch them. It's such a pleasure. But coming back to the whole thing, lunar eclipse was a big proving point of why the Earth is flat. I can't believe I said that. Why the Earth is round. Why the Earth is round, guys. Slip of tongue happens. Why the Earth is round, okay? So let's understand what a lunar eclipse is, okay? There are 3 characters in play, okay? In a lunar eclipse, there are 3 characters in play. There's the sun, there's the Earth, and there's the moon. In that exact order: sun, Earth, moon. Now, the sun is always casting Earth's shadow into outer space. Let's understand this by using an image. Martin. All right. So as you see in the image, the sun is always helping Earth cast a shadow out. Like wherever the Earth is, the light in that particular region is actually blocked. And when a lunar eclipse happens, when the moon is directly in this line of sight, when the sun, the Earth and the moon are aligned in the same kind of line of sight, okay? And then what happens in this case is the shadow of the Earth is reflected onto the moon. Okay, that is essentially what is happening over here, and you can see brilliant colors sometimes. Like for example, the moon turns insanely red because slightly you can see the reflected rays of the sun that is sort of passing onto the moon, and only the red wavelength actually manages to sort of reflect off from the lunar surface. So it's a really brilliant thing to watch. I think all of you should sort of have an experience of a lunar eclipse. There's a lot of superstition that is attached to this whole thing. I mean, if you choose to believe in it, that's totally like your free will, but there's no scientific base to any of these superstitions. But this is basically what it looks like. Like you see in the image, there's a shadow. Now, let's move on to the next picture. When the moon actually comes in the line of sight of this shadow, the Earth, a small part of the Earth is actually casted onto the moon. So the image that you see on the top left, the Earth is actually in a very curved format and it's not in a flat format. So this is another point that solidly proves that the Earth is not flat and it's actually spherical in structure. And I'll actually show you how the shadow would look like if the Earth were actually flat. Martin, can we see the next one? Yeah. Do we see that, guys? Do we see that? This would be hilarious if we actually saw that. Like, just imagine. This would be hilarious. We do not see this during a lunar eclipse. We do not see this in a lunar eclipse. But can we go back to the next slide? Sorry, previous one. Right. Okay. So here another question is, what if the disk was actually not like, what if the disk was not perpendicular to the moon, but is actually in the same line of sight of the moon? Like for example, the previous slide that you saw where the whole flat earth thing I was showing, that is if the moon is like this and if the earth is like this, if the flat earth is like this. But what if the earth was actually flat and the disk was actually like this instead of this. Even then, we would actually expect to see something like this. Then how can this image even prove that the Earth is actually not flat? This was actually disproven by a scientist. These are all like 1,000, 2,000-year-old scientists. Like, these guys were mad geniuses. They didn't have like crazy as equipments to work on, but they had insane amount of intelligence. So there was a scientist who actually went to different parts of the world during lunar eclipses, and he actually saw the same thing. If the Earth was actually flat like this, he would expect to see different kinds of images from different points in the world. But wherever he went, whichever city he went to and saw the lunar eclipse, he always saw that the image was actually round. The image was actually curved, which again only establishes the thing in stone that the Earth is actually not flat and it's round. So, quick recap. 3 reasons. We explored 3 reasons why the Earth is not flat and it's a perfect sphere. Okay. Number 1, the sailboat example. The further you go, you start losing sight of the base of the sailboat. Like, there's a sailboat that's going in the sea, and the further it goes, it starts sort of dipping, and you only see the mast. And even when a sailboat is actually approaching towards you, you see the mast first, and then you see the whole ship. That's point number 1. Number 2, Aristoteles, the whole well experiment that he did, he measured the angles of the sun that were falling on different cities at the same time, and using those angles and plugging into certain equations, he established that the Earth was actually, that such angles could only be obtained if the Earth was round and not flat. Okay, so that's another mathematical proof. And the final thing being lunar eclipses. In lunar eclipse, you actually see a curved shadow. Someone actually went to different cities around the world and saw if they were actually seeing the same curved shadow at all places or not. And they actually did end up seeing the same shadow. So lunar eclipse becomes the final point of why the Earth is actually not flat. So sailboat, remember that. The well experiment by Aristoteles and lunar eclipses. These 2 things, I want all of you to go try it whenever you can after lockdown. I want all of you to sort of take the spirit forward and see these things for yourselves. Question, no matter how obvious things seem, it's such a delight to actually experience it for yourself and actually see the process right in front of you and to confirm it. It might seem really stupid. I mean, like, what the heck am I even doing watching a sailboat going into the horizon? It seems ridiculous, but trust me, it's not. Try it out. You'll know it for yourself. It'll make you feel really good, and it'll ignite a spark of experimentation, the spirit of experimentation in you. And I want all of you to sort of carry that forward as well. All right, awesome. Now here's the thing. Neil deGrasse Tyson. One of my favorite astrophysicists is Neil deGrasse Tyson. He is a big inspiration of mine. And there was a rapper called B.O.B. who tweeted that the Earth is actually flat and it's not round, and he was becoming this huge as flat earther, and he was the one who actually made the statement that actually made it initially. He literally tweeted, once you go flat, you never go back. Haven't heard anything more stupider than that. But there's an amazing video where Neil deGrasse Tyson came on a talk show and he was spitting fire. He thought of responding, being the sport he is, he thought of responding to this rapper in his own language. So Neil deGrasse Tyson wrote an extremely scientific rap, which I think is hilarious. So I want all of you to sort of see that. Neil deGrasse Tyson and his savagery. Martin, let's have it on the screen.
I'm sorry. Here, you take that. Here, you ain't. Oh my God. Okay. Oh.
All right, listen, B.O.B., once and for all. The Earth looks flat because, 1, you're not far enough away at your size. 2, your size isn't large enough relative to Earth to notice any curvature at all. It's a fundamental fact of calculus and non-Euclidean geometry. Small sections of large curved surfaces will always look flat to little creatures that crawl upon it. But this whole thing, it's just a symptom of a larger problem. There's a growing anti-intellectual strain in this country. It may be the beginning of the end of our informed democracy. Of course, in a free society, you can and should think whatever you want. And if you want to think the world is flat, go right ahead. But if you think the world is flat and you have influence over others, as would successful rappers or even presidential candidates, then being wrong becomes being harmful to the health, the wealth, and the security of our citizenry. Discovery and exploration got us out of the caves, and each generation benefits from what previous generations have learned. Isaac Newton, my man, said, if I have seen farther than others, it's by standing on the shoulders of giants. I get an amen. Woo. So that's right, B.O.B. When you stand on the shoulders of those who came before, you might just see far enough to realize the earth isn't flat. And by the way, this is called gravity.
Was that savage or was that savage? That mic drop. I so badly wanted to actually do a mic drop over here, but Martin did not let me. Martin's the video editing guy. He's like, don't touch my mic, Sid. I'm gonna kill you. But anyways, was that savage or was that savage? Insane. Neil deGrasse Tyson, ladies and gentlemen, presenting you the man himself, the legend. Hope you like that. Okay. Now, coming to the end of this, there was one question that I started this entire discussion with. And that question is, why do people still believe in flat earth? Like, people believe in a lot of different stupid stuff. Like, there are people who don't believe that climate change is real. There are people who believe you should not get vaccinated despite a lot of scientific proof. So there's this whole thing going on. Like, there is so much research that is happening. Science has advanced a lot. There is so much media that's happening, media communication that's happening. Information is going everywhere. There are credible sources that you can actually verify. There is data available as open source. You can literally go to certain websites and access these databases for free and verify it yourself. There is such level of information that's available. There's such level of research that's going on and credibility that is associated with such researches. Why do people still believe in things like vaccination is not real, or the earth is flat, or there's a religion called what is that religion called, Scientology, and stuff like that? It's really weird as a race that even though most of us have sort of come ahead, there is still a few of us that is sort of in the dark, and they choose to sort of live in ignorance for some other reason. And for them, it might not even seem like ignorance. For them, that is their reality, because they've chosen to sort of live in that and believe in that reality that there is. And an interesting sort of explanation for this is, back in the days when we were hunter-gatherers, when we were cavemen, the only goal that we had was to survive until the next day. Survival was a big deal. It was a big deal. Every single day was life or death. You could get eaten by a tiger. Such were the things. And shelter was not available sometimes. You could get sick. There were no doctors. We were literally cavemen who were just living out there in the wild. And there are certain times when if we believed in certain things, 9 out of 10 times it would not work, because they're only beliefs and there's no science that actually backs it. But 1 out of 10 times it came out to be true. 1 out of 10 times, just out of pure luck, like when someone believed in certain things, it just came out to be true. Because it's pure statistics. Like, for example, if it was like raining or something, and if I sort of made a little prayer and I'm like, hey, if I make this one prayer, the rain is gonna disappear in 5 minutes. 9 out of 10 times the rain won't disappear, but just 1 out of 10 times it might just disappear because of luck. It might just be timing. It's just pure coincidence, but it works. But what happens at that point is it made that man or woman believe that, hey, my prayer or my belief or my superstition, whatever I did at that time, like they must have chosen to do a prayer, they must have chosen to sort of hug a tree or whatever it is, whatever bizarre thing that they believe in, they end up believing that what they did sort of influenced this action. So there is a kind of a genetic predisposition there is a kind of a genetic predisposition that we have to superstition. There is a superstition gene that we all carry forward with us, like right from the days. It's very instinctive within us. That it's all there embedded within us. It's almost like it's like an evolutionary memory that we have. It's like this thing that we have like right from the past, and a lot of the the amygdala activation can sort of be correlated to this. But basically, the point I'm trying to say is we still carry some of those instincts with us forward even now. And one interesting example is if you show a cucumber to a cat. You must have seen these videos on Instagram. If you place a cucumber in front of a cat, the cat will get shit scared. Why? Because the cat used to live in the jungle and it's programmed to be afraid of snakes. And that's why even if it sees something vaguely similar to that, it gets really scared. And that's the kind of evolutionary programming it has in its genes. And we kind of have that because sometimes it has genuinely helped us out. But it is our responsibility to actually grow out of it, because right now we don't live in such dark ages. We have information to keep us informed. We have accessibility than ever before. We have comfort than ever before. And it all comes down to us in order to make leverage of all those things and be well informed about our own opinions, about our own thoughts, and about our own choices, so that we can question and know what is truth and what is not. But what do we do about the other people? What do we do about the people in the dark who choose to be in ignorance? Well, we can't do much. All we can do is we can deal with it slowly, painfully, carefully, persistently, in order to slowly bring them out of this whole thing. Probably a couple of years down the line also, we'll have a number of people who are believing in some kind of nonsense. And we're a population of 7 billion. It's inevitable. I mean, of course, you have the right of freedom of speech and the right to free will and think whatever you want and all of that. But at the end of the day, if you're thinking crap, that's on you, my friend. That's not on any of us. With that, this was a lovely, lovely session. I hoped you enjoyed the flat earth debunking. You have 3 reasons to tell your friends of why the earth is not flat. If you want to watch the rap, go to Comedy Central to watch that. And don't miss watching that Vice video that I spoke about in the beginning. It's called Inside a Flat Earth Convention. It's a really interesting video. I want all of you to go watch it right after this. Crazy good content. And before we leave, like this video, comment what exactly you liked about this, and hit the subscribe button and the bell icon to get notifications. Until next time, your friendly neighborhood science nerd, Sid, goes on out.